Okay, so here's the video for section 8.1. And in this video, we're going to know to perform hypothesis testing when we have two samples. So in this case, we're going to be testing the difference between our means, and our samples have to be large and independent. So we consider samples to be independent when the sample selected from one population is not related to the sample selected from your second population. The opposite of that is when they're dependent, and this is when the members of one sample are going to correspond to your members of the second sample. Sometimes we also call dependent samples paired samples or match samples because each of them have a pair or a match in the opposite sample. So I have a little graphic here that illustrates the difference between independent and dependent. So you'll notice with dependent, we have our matches going on. Each thing in sample 1 is corresponding to something in sample 2. Okay, so for these first two examples, we want to classify them as independent or dependent and justify our answer. So we have sample 1 is the weight of 65 college students before their freshman year, and the second sample is the weight of the same 65 college students after their freshman year. So this one is dependent. And this is dependent because the sample 1 matches to sample 2. It's the same person, just weight at a different time. All right, example 2, we have sample 1. It's the scores of 38 adult males on a psychological screening test for ADHD, and sample 2 is the scores of 50 adult females on the same test. All right, so this one is independent. There's no way that you can pair this up because they are different people. Okay. All right. So I have two more, and I want you to pause the video and answer these two questions. Okay, so hopefully you got independent for this first one. You cannot pair these up. And dependent for the second one because it's the same students at a different test. All right, so just like we have been practicing for a while now, your null hypothesis is going to say that there's no difference between the parameters of the two populations. So in this case, we're always going to have our equal with the null hypothesis. With your alternative hypothesis, remember this is going to be true in your A false. It's going to contain your symbols of greater than, not equal to, or less than. So now that we are comparing two different means, these are the three different types of combinations you could have for each of your tests, two-tailed, left-tailed, right-tailed. So in the first example, we're saying that the means are equal to each other, and the alternative then would be not equal to each other. And you can see the corresponding less than or equal to, greater than or equal to, less than, okay? So no matter which one of these tests that we use, we're gonna assume that there's not gonna be a difference between U1 and U2, and that's gonna come into play with our formula, okay? So don't stress out about that yet. I'm gonna show you what I mean with the formula when we do our examples. All right, key things to keep in mind. You need to know the population standard deviation. You need to pick random samples. The samples have to be independent of each other, and the population has to be normally distributed, or each sample size has to be 30 or more. Okay, so to find the mean, what you're going to do is you're going to actually subtract U1 minus U2. And to find the standard error, you're going to use the population variance divided by your sample, okay, as shown by this formula. And sometimes we will be substituting our sample variance for these. We just need to make sure that our sample size is large enough. Okay. So our test statistic in this case is going to be the mean of sample 1 minus the mean of sample 2. And to find our standardized test statistic, we are going to use the following formula here. This U1 minus U2, that's the 0 that I was talking about on one of the earlier slides. Okay. So again, these are our conditions that we need to have for this. All right, so let's run through all the steps. So you need to make sure that your population standard deviations are known, and make sure that your samples are random, independent, or normally distributed. And normally distributed, or your sample size have to be greater than or equal to 30. State your claim, identify your null and your alternative, specify the level of significance for the test, determine your critical values. You can use the table in the back of the book, or you can also use your calculator. Determine your rejection region, and then use the formula to find your standardized test statistic. Once you've done that, you can make a decision whether or not you're going to reject or fail to reject, and then you're going to write your summarizing sentence. Okay, so very similar to what we've been doing. Now we just have 2 samples instead of 1 sample. Okay, so the formula we use will be a little bit different because of that. Okay, so a credit card watchdog group claims that there is a difference in the mean credit debt in households in California versus Illinois. A random survey of 250 households from each state was taken. The 2 samples are independent. Assume that U1 is $4,446.25. And the standard deviation that goes with that is $1,045.70 for California. And mean 2 is $4,567.24, and the corresponding standard deviation is $1,361.95 for Illinois. And we want to know whether or not the results support the group's claim. Our alpha level in this case is 0.05. Whew, okay, so we got a lot of information going on. So, okay, so in this case, our claim is that there is a difference, which means U1 is not going to be equal to U2. Okay? And the complement to that statement is going to be that they equal. Okay, so notice in this case they said there's a difference, but they didn't say if the difference was greater than or less than. So that's why we're going to be using the equal and the not equal. Okay, so we have our null hypothesis, and we have our alternative hypothesis. Okay. Okay, so from the alpha level of 0.05, I know that since this is a two-tailed test, and I know it's a two-tailed test because I have an equal sign, so two-tailed. That my Z naught is plus or minus 1.96. So what this means is if I have my curve, so if I have my curve, my rejection, oh, that's supposed to be a 6. My rejection region is going to be anything less than negative 1.96 and anything greater than 1.96. Okay. Okay, so the first thing that I'm going to do is I need to find my standard error. And to do that, I'm going to use the following formula. So in this case, we are allowed to substitute in our sample standard deviations for our population because our sample size is large enough. Okay, so I'm going to go ahead and plug in for this formula. And I'm going to get 1, 0. Okay, so if I plug that into my calculator, I'm going to get about 108.598.3. Okay, so now that I have that, I am going to write down my Z formula. So we are going to do Z equals probably takes me longer to write this down than actually doing the math. Okay. So let's plug in. We're going to get Z equals 4, 4, 4, 6, 25, minus 4, 5, 6, 7.2, 4, minus 0. So this is the one that I was saying always is going to equal 0 regardless of which pair of null and alternative hypotheses you have. Okay, so if we plug all that into our calculator, we're going to get negative 1.11. And you'll notice that that is here, so we will fail to reject this. Okay, so let's write our summarizing sentence. There is not enough evidence to support the claim that there is a difference in the mean credit card debt for California and Illinois. Okay, let's do another example. All right, so on this next example, we have a survey that indicates the mean annual wages for forensic science technicians working for local and state governments are $53,300 and $51,910 respectively. The survey includes randomly selected samples of 100 each from each government branch. Population standard deviations are 6,200 for the local and 5,575 for the state. 2 samples are independent. Alpha level is 0.10. Is there enough evidence to conclude that there is a difference? Okay, so in this case, we have our claim that there is a difference, and so this one is going to look very similar to the last one that we did. Okay, so our claim in this case is that there is a difference. So that means that mean 1 is not equal to mean 2. And the complement to that statement would be that they are equal. So we identify the claim is our alternative, and this is our null. Okay, so the other thing that I kind of like to do with these is organize my data. So I have local, and I have my state, and I'm going to call my local is going to be 1 just because it came first, and this is going to be 2. So anytime I then plug in, you'll know what I'm talking about. All right, so then I'm going to write down my mean, I'm going to write down my standard deviation, and I'm going to write down my sample size. Seems kind of silly to write down the sample size since they're the same, but I'm going to write it down anyway. All right, so Local mean is 53,300. And 6,200. And 100. Okay, state is 51,910. 5,575. And 100. Okay, the other thing to keep in mind that, again, we have a two-tailed test, except this time my alpha level is 0.1. So my z in this case is going to be plus or minus 1.645. Okay. So again, just like the last example, we're going to have two rejection regions to the left of negative 1.645 and to the right of the positive. Okay. So now that we have that, we're going to find our standard error. Trying to give myself a little bit more room to write. Okay, come on. All right, so let's see. Find our standard error. Okay, so we are going to use the following formula. So S1 squared over N1 plus S2 squared over N2. All right, let's see if I can squeeze this all in here. So S1 is 6,200. All right, so if I plug all that into my calculator, I am going to get 833,790. All right, fantastic. Now let's write down our Z formula. So we have all right. So 5, 3, 3, oop, 3 minus 519. So again, mean 1 minus mean 2, we are assuming that is 0. Okay. So if we do that, we get a z-score of 1.67. Oops. Okay, so that is in between, no, it's greater. So it's here, 1.67. All right, so since it is in the rejection region, we will reject H naught. So we're going to say there is sufficient evidence at the, what's our alpha level? 10% significance level to support the claim that there is a difference in the mean in annual wages. Oh, just trying to move it up, but I ended up. Okay, let's go back to this. Come on, I want to scroll down. There we go. Okay, you see this? There we go. Okay, so there is sufficient evidence to reject. All right, now I'm going to show you how to do this in the calculator. Okay, so for the next example, we have a travel agency claim that the daily costs of meals and lodging for vacationing in Texas is less than Virginia. Okay, so in this case, our claim is that Texas is less than Virginia. So the complement to that is going to be that U1 is greater than or equal to U2. All right, so our null is here, and our alternative is our claim, okay? So in this case, we are going to use the calculator to determine the p-value. The only other thing that I'm going to add to my chart here is that this is $19 and that this is $24. Okay, so I'm going to type out the calculator steps. So first, you're going to hit stat, and then you're going to scroll over to test. And then from there, you're going to pick the 2 sample Z test. Okay, and you have 2 options here. You have data for if you had your information in a list, and then you have stats for when you know the information. So in this case, we have stats. So then you're going to fill in the corresponding values, and you're going to choose your alternative hypothesis, and you're going to click calculate. And so once you do that, you are going to notice your p-value. In this case, your p-value is 0.1807. 1807. 1807. Okay. So in this case, our p-value is greater than our alpha. So remember, when p is greater than your alpha, you are going to fail to reject. Okay. So let's write our sentence. There is not enough evidence at the 1% significance level to support the travel agencies. All right, we have another example, and I think you should try this one. You can use your calculator. Okay, so hopefully you had a chance to try. Let's go ahead and work through this. So we have a random fast food study. Researcher is trying to figure out who has a higher, or if Long John Silver's has a higher sodium content than Wendy's. Okay. So in this case, we have two restaurants, Long John Silver's. Oh, I was going to put a G. Long John Silver's. I think I did that. Yeah, I did that on my notes. And we have Wendy's. That's funny. So we're going to call Long John Silver's 1. And we're going to call this one 2. Okay, so we're going to put our mean, we're going to put our standard deviation, and we're going to put our sample size, and then we're going to plug it all into the calculator. So we are trying to see, the claim is if Long John Silver's has more sodium. So our claim is U1 is greater than U2. The complement to that is less than or equal to mu2. All right, and then our null is here, and our alternative is our claim. All right, so let's put all the information on the chart now. So we did measured the sodium content from 39 Long John Silver's sandwiches, and we got a mean of 1180 with a standard deviation of 90. Then 42 Wendy's sandwiches with a standard deviation of 1010. And standard, oh, I think I said standard deviation, mean of 1010, standard deviation of 75. Okay, so if I plug that into the calculator, I'm going to get a p-value. I'm going to type this. So from my calculator, I'm getting P is equal to 1.86 times 10 to the negative 20th. So that is a very, 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 very small p, which means this has a really small probability of occurring. And the question is that less than my alpha level of 0.05? You bet. So that means we are going to reject. All right, so let's write our sentence. We can say there is sufficient evidence at the 5% significance level to support the researchers' All right, so the last thing that we're going to talk about today is confidence intervals. And so this example wants us to construct a 95% confidence interval for mu1 minus mu2 and assume the samples are random and independent and the sample statistics are given below. So we can actually perform this in our calculator. So the calculator steps are as follows. So step number 1, you're going to hit stat. Step number 2, you're going to go over to tests. And then step number 3, you're going to scroll down to sample Z interval. Let me make sure I type that right. This is all like one thing. Yeah, 2SAM Z int. Okay, so from there, it's relatively easy. Just make sure you plug things into the right spot because it doesn't necessarily go in the order that it's given here. So once you type that all in, make sure you put the appropriate confidence interval. In this case, it's 95%, so you're going to put 0.95. And then you're going to just click calculate, and it'll give you negative 2.209 and 0.208. So then you could just say with 95% confidence, the difference of mu1 minus mu2 is between negative 2.209 and 0.2086. And we're done.